1 over the naked There you go. Answer all the questions in my head.
All right, sine of 3 pi over 4. What you got, guys?
Square root 2.
Root 2 over 2. Good. What about cosine of 7 pi over 6? Oh, tangent of 4 pi over 3. Positive root 3. Good. Okay, now, guys, starting this quarter, we are adding in cosecant, secant, cotangent to your time trig quizzes. Okay?
Oh, it's just like the opposite.
Not the opposite. Opposite would mean change the sign.
Reciprocal.
Yes. Cosecant is related to sine. So, guys, what is the sine of pi?
3, not 1.
0. What is the reciprocal of 0?
Also 0.
It is not also 0.
Undefined.
Undefined.
I don't know why the reciprocal of 0 is 0, but I did have undefined at the end.
Okay. 0. Correct? Reciprocal of 0.
This is what I have. 1 over 0. Because cosecant 1 over 0.
All right, guys. Secant is related to cosine. What is the cosine of 2 pi over 3? Negative a half. So what is secant going to be?
1 over 1/2 making a negative 2.
Cotangent of 3 pi over 4. Krish, bring your phone up. Yep, negative 1. Thanks. Cosecant related to sine. So sine of 5 pi over 3 is... Yes. So when I flip that, what do I get, guys? Over 3. Yeah.
I'm so smart.
All right, tangent of 3 pi over 2. Undefined. Good.
No, it's U, B.
All right, questions on those?
7.
Number 7? Okay, are you good with sine of 5 pi over 3 is negative root 3 over 2? You're good with that part? Okay, so then flipping it, we can't leave it like that. We rationalize. Tyler, are you good or are you sure? Okay, yes. And guys, again, you know, when we do these timed, you have to be pretty efficient at it. You don't want to have to write out your rationalizing every time. Like, you should get to the point where you know, okay, if I flip root 3 over 2, it's 2 root 3 over 3. If I flip root 2 over 2, it's root 2. Like, it's the same numbers over and over, guys. So start to know those, okay? All right, notes. We are starting skill 7.
Oh, so exciting.
Trig inverses today, guys.
That sounds like
It's actually not bad at all. Okay, guys, this is absolutely not a graphing skill, but we're going to draw a couple graphs so you understand why we do the things that we do. But again, you're not going to be assessed on graphs at any point during this skill, okay? This is just so you understand what's happening. So the first thing we're going to do is graph the parent graph of y equals sine of x. So let me draw. Normal period, parent graph stuff, okay? Hopefully we know this. All right, guys. Everybody's good with graphing basic sine graph, right? Okay. What do you remember about inverses from inverses in algebra that you've done so far? What do we know? Anything about inverses? X and Y switch, and what are close? They reflect over the line y equals x. Like, is that what you're thinking about? Maybe. Yeah. The big key is that the x and y are switched. So we're going to draw the graph of y equals inverse sine of x. And it's not scary. It means your x and y axis are going to switch.
Oh my god.
So on the x-axis, I'm now going to go from -1 to 1.
This is interesting.
Y-axis, go up to 2 pi. I know those labels are small, but you guys know what they are? Well, I'm asking, do you know what they are?
Yeah.
And then we're just going to plot our points for the inverse. So again, we're going to switch the x and y. So that first point that's at 0, 0, when you switch 0 and 0, you get
0. Yay.
Well, 0, 0, right? Not just 0. Okay, the next point, I could label it as pi over 2, 1. So what am I going to plot on my inverse graph? 1 pi over 2. There we go. The next point on my graph is pi 0. I'm going to plot 0 pi on the inverse graph.
So I can see them back over the side.
3 pi over 2 -1 will give me -1 3 pi over 2. And the last one, pi 0 is 0 2 pi. Now, you could plot all the points on the left side, or do you guys see the pattern? Can you follow it? Okay, that's what I would do. And then you can draw in inverse graph. Anybody questions on making the graph? Okay, is that a function?
Maybe. Yes.
No, it's definitely not a function. Vertical line test would definitely cross that more than once, right? Okay, that's what I mean by function. That is not a function. So what we have to do is we have to restrict this and pick a window that's going to show all the values of the graph, but is a function. Anybody have a guess on a window we might want to use? You don't have to draw an asymptote. Here, let me show you. What if I did, like, what if I only looked at this part? It kind of looks like the tangent graph, but you guys see how that is a function?
Yes.
Okay, right? That's...
What does it cost back over?
Yeah, we're going to stop there. So when we're talking about inverse sine, We are restricting the window. The only thing we can use is negative pi over 2 to pi over 2. There are other windows that would give you those same values, but this is like the accepted window that we use when we're answering inverses. So this is it. This is all we get to look at. Does that make sense? The whole reason we're graphing it is so you can understand why I'm telling you these windows, okay? Because that's how we're going to answer questions. So I want to make sure you see like where it comes from.
Wait, is that domain or that's domain?
It's technically the range. Domain would be -1 to 1. But we restrict the range to only look at this little section so that it's a function. Okay? We're going to do the same thing with the cosine graph. Guys, we're not going to do this with all 6 graphs, okay? Just sine and cosine. So I want you to graph for me your parent graph for cosine, and then try to graph inverse cosine for me. So take a minute here in your notes, see if you can get those figured out. Check in with your neighbor.
Maybe you're green.
Guys, talk to each other, look at your graphs.
The line that
You think you've got your inverse graph? Are we going to use the same window that we used on the other one? Look at it, see if you can figure out what window you would use.
Okay.
Can you have 2 windows?
Yes.
No, you have to pick one window.
Is there more than one option though, or is there only
So there are lots of options that would cover it. There's one like accepted option, if that makes sense.
Just say,
Yeah.
for the window. Oh yeah, from 0 to pi. No?
All right, good with the graph?
Yes.
Okay, the window we are picking this time is what, guys?
3. Oh, 0 to pi.
We're going to go 0 to pi. There are other ones that would give you a function, for sure. But 0 to pi is the one we are going to use.
Wait, but with that logic, it's like, could you do I to pi?
Yes, like that would give you the same answers, but what I'm saying is the interval that's like accepted for answers is this one. You're not wrong. We could pick something like well beyond 2 pi that's technically also giving you the same values, but this is the window we will answer it. And you'll see in a second like what I mean by that. I'm just gonna establish the window first. Okay, we're not gonna graph the rest of them. We could graph tangent, cotangent, secant, cosecant, all of those things. We're not. You guys are going to trust me on the window based on this. Like, you get how we're creating the window from the graphs. Okay. So let's draw some circles. I know you guys don't have a circle drawing tool, but draw a couple of circles for me. I did good drawing circles just on my whiteboard today too, so.
My circles are basically rectangles.
You can trace around your water bottle.
Good idea. That was a genius idea, Mr. Lee.
Hey, thanks. Okay, guys, this first circle, the right-hand side of it that I've outlined in red. Do you guys see how that's negative pi over 2 to pi over 2 value-wise?
For what?
What's in red?
No.
I haven't said yet. Just in general, do you agree that's where negative pi over 2 is and where pi over 2 is? Yeah? Okay, that's all. We said the window we would use for inverse sine was negative pi over 2 to pi over 2. Hey guys, will you shut your laptops for me too? All right, so this is inverse sine. We know we're going to use this window for that. What window did we pick for inverse cosine? 0 to pi, right? So isn't that the top half of the circle? Yes, okay. 0 to pi. All right. We have those other 4 trig functions that have to fit with one of these 2 little options here. So guys, secant and cosecant, which one goes with which? What does secant go with? Okay, so inverse secant goes over here. Where do you think cosecant goes? Okay. Now, tangent and cotangent are split up. One of them is going to be in the red circle, one's in the blue circle. If you think about it with tangent, your asymptotes were at pi over 2 and negative pi over 2, if you remember graphing it. So inverse tangent goes on the red side. Cotangent had asymptotes at 0 and pi, so inverse cotangent goes over there. Is that like a question or just a yawn in the middle or something?
I missed. How do you get all the other besides like sine?
So you've got sine and cosine, right? Okay. Cosecant's related to sine, right?
Okay, so it's just one related to it.
Kind of, but tangent and cotangent are split up. If we had graphed them, tangent has asymptotes at pi over 2 and negative pi over 2. So that's why it goes with the red one. Cotangent at 0 and pi. Okay. All right. I'm going to label things in the circle. It's stuff you know, right? We know this is pi over 6. I'm going to the blue circle first. Pi over 4, pi over 3, pi over 2. Second quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then that's pi. Again, guys, if you still haven't learned your circle, it really is time, okay? You've put it off long enough. You need to know these values on your circle. If I ask you an inverse cosine, inverse secant, or inverse cotangent question, these are it for your answer options. You can only tell me those answers in blue. That's it. Okay? We'll do problems here in just a second so you see. The red circle, first quadrant is normal, right? Pi over 6, pi over 4, pi over 3. This is 0. Now into the fourth quadrant, normally that would be 11 pi over 6. But that's not what it is for us. Negative pi over 6, yes. Negative pi over 4. Negative pi over 3.
This is what you wrote on the whiteboard, but now it's power now. Okay, just making sure.
Yeah. Yeah, no, I just had no power during third period, so that's why I was up there.
They were really good circles.
Thanks. No circle tool. Okay, so let me show you what a question is going to look like for this. And I'll keep scrolling back up to this so you can see it. The directions will be kind of like your warm-up. It'll just say evaluate. All right, there you go, guys. Inverse sine of 1/2. Jot it down. I'll explain how we do it. Henry.
Sine of inverse.
Inverse sine of 1/2. Okay, let me scroll back up so you can see the circles. We'll figure out how we answer this. So it's inverse sine, which means I can only use this circle, right?
Correct. Like always.
Always. They're never going to switch. Okay. So inverse sine is always just this side of the circle. You cannot give me answers from over here. This is it. It was positive 1/2. So do you think I'm looking at a first quadrant or a fourth quadrant answer? First. So out of these, which of these has a sign that is equal to 1/2? pi over 6. That is the answer. That's all you're doing. It's like your trig values in reverse. That's it. I mean, we're going to do several examples, but that's it. Yeah.
Will it ever be a common graph? Like right now we have three.
I'll show you one that's like where you have to draw a triangle. But most of the time it'll be a circle.
Most of the time we just able like to find on the circle.
It's literally like, so we're using these circles because it's sine.
All right, inverse cosine negative root 2 over 2.
No.
That part of the circle. So first or second quadrant? Second. In the second quadrant, where is cosine equal to negative root 2 over 2? Just 3 pi.
Negative uno.
Think it through, guys. Don't just shout it out yet. I'm glad you're excited. Probably next class. Everyone in here who missed the test last time is also absent today, so I hope they pick it up. I'm sure we're there.
I'm not here about you. Nobody's doing that. We're just like, let us see it for a second.
All right, guys, what do we get for this one? Negative pi over 6. Did anybody write down 11 pi over 6? It's not right. I just want to see if anybody write it down. Remember, these are your only choices for answers right now. That's it. So it was tangent of negative root 3 over 3. So red circle. Negative means it's fourth quadrant. Over 6s, or where tangent is root 3 over 3, so you know it's going to be negative pi over 6. Okay, let's try again. That is what I wrote. Yep. Once you see this, it's.
Why do we go to proofs? Why? We should just.
Yeah, why? We literally just like
proofs are losers. They might go down.
So, this is 7-1. There's more of this. And the formulas from last skill will reappear in the solving. So, not more proofs. Oh, it would be really nice, though. You know all the windows. You can go do it. All right, guys, what do we get? Negative pi over 4. Okay. Cosecant is related to what? This is like asking inverse sine of negative root 2 over 2.
How is that like that?
Well, when I flip, if I do the reciprocal of that, no, you're supposed to know your trig values coming in.
Oh,
Okay.
that's kind of that on the test.
You need to recognize what that is. Like, that part's not new. You gotta recognize those. Like, if you see 2 root 3 over 3, you need to know what that is. Okay? The reciprocals are not new. Do you guys believe me yet that knowing your trig values will make things easier for you?
Yes.
All right, let's try this.
Oh, wait.
You panic so quickly.
The wind inside.
Oh, great, here we go.
Yeah. This really should have been a test last year.
Oh my God.
Get reviewed.
I didn't say anything.
Henry, put your phone away. Guys, phones away. All right, what do we get? Do we have an answer? Root 3 over 2, yes. Okay, let me walk you through it in case you're stuck. Start on the inside. Inverse cosine negative 1/2. That is 2 pi over 3. Okay, that's second quadrant where cosine is equal to negative 1/2. Then you are back to just a regular trig value. What is the sine of 2 pi over 3? It is root 3 over 2. I mean, pretty much. There's not that much. I can keep making them up, but... Let's do another one kind of like that. We are gonna do. Yep. Let's do. Actually, we'll do this. Okay. And then, guys, one more example after this. That's it for now. We'll do 7. Make it check with your neighbor. How'd we do? Neighbor.
Is this a minus?
It is. I got some new markers.
It's a good one.
It's magnetic and it has its own eraser.
That's crazy.
All right, guys, what'd you get as an answer? Root 3 over 3? Yes. I was like, we got some. Let's go through it. So this is like asking, where does cosine equal root 3 over 2? That is at pi over 6. And then the tangent of pi over 6 is root 3 over 3. You do not have to write out that work. Like, I'm okay with you just knowing these and doing them in your head and writing the answer. That's fine. All right, questions on that one? Again, if you know your trig values, it's pretty straightforward. If you don't, it's kind of hard. All right, one more, guys. Oops, not inverse cosine, sorry. I have not shown you one of these. See if you can figure it out. I'm going to give you a minute.
Are you kidding me?
What? Yeah, you can. Draw a triangle. There's my nudge, okay? All right. You're like, okay, step one done. In that triangle, can you find the cosine?
Is that it? Is that an answer?
Oh, that's.
It's super simple.
Oh.
It is. Well, what do you think? Depends on where you drew your triangle.
4 or 5. That's incredible.
How do you know?
All right, let's. Okay, so
Guessing it's third, fourth one.
we're gonna draw a little triangle here.
It's like way less. It's like a way.
Okay, it's inverse sine of negative 3/5. Inverse sine. What are your only two quadrants it could be in for inverse sine? 1 and 4. Which of those would sine be negative in? 4. So we're going to draw our triangle in because of that. It's still that, okay? So do you guys see how the other side has to be positive 4?
Yep.
Okay. So that's the angle we're talking about. Now what is the cosine of that angle? 4, 6.
That is so.
Okay. Questions, guys? That is notes. Quick notes. Let's do, because we have one. Oh, I didn't fix my clock.
It's 12:42.
It is 12:43. I'll fix my clock in a minute. Let's do quizzes first, and then we'll see how time is. We might do whiteboards also, okay? Or we might do, here, let me double check. How many quizzes do I want? Oh, and guys, notation-wise, something to make sure you know. Those are asking the same thing, guys. Inverse sine, or if it says arc and then sine or cosine or tangent, it means the exact same thing, it's just a different notation. Okay?
Oh, arcs is just.
It's the same thing. It's just another way you can write it, but it means the same thing.
It's what I was.
Some of them are, so I didn't want you to be shocked. Drew, what?
What is the arc?
Means the same thing. Like those are the same question, just written two different ways. Yeah.
Yes. Try to get wrecked. Say that every time. You are actually going to
Is this going to be on a test play or just for the next one?
No, this is part of your assessment. Yeah.
They're all laughed after the teacher that came on screen.
Yikes.
Like that down, guys.
Maybe we should just put up our little window cover and ignore them. No one's here.
Never mind, Ricky. We have not good power, so you can get it. See, I have a secret to how I get such good power.
I guess you're not going to share.
No, it's got at least evidence. No, Julian, I have legit power up, so I might give you some extra. Just Oh man, we have 100
All right, guys, everybody in? All right, I'm starting. You can still join. Wow, that is a lot of. No, it's a lot. A lot of a lot. So again, the arc is the same as inverse, okay? Means the same thing.
The exact